Hi friends, see in thermal properties of matter in part 1 we have discussed about so many things regarding, that is, different types of scales, expansion of solids and also we discussed about the various formulas. Now in part 2, thermal properties part 2, thermal properties of matter part 2. Okay, in this we'll be discussing about the simple pendulum. That means, for example, a pendulum is there. For example, the length is L and we know the time period formula T is equal to 2 pi into root over L by G. We know the time period T is equal to 2 pi into root over L by G. Now what we want to discuss now, today's class is, suppose if the temperature is increased, suppose if the temperature is increased. So what happens? Length will increase, therefore T is directly proportional to root L. Temperature పెరిగితే length పెరుగుతుంది. So length పెరిగితే time period కూడా పెరుగుతుంది కదా. Time period పెరగడం అంటే what is meant by increasing time period? That means it is taking more time to come back. It is taking more time to come back, time period. That means the time is becoming slow. Okay? So the time becomes slow. So here loss is there, loss of time. Here what happens? Loss of time. That means when you increase the temperature, length is increased, time period increased. That means it takes more time. That means time becomes slow. So loss of time. So in such cases, how to get the formula? See, we have one formula also for this one. That is, I think, delta T is equal to half alpha delta theta into T. We have one formula, delta T, change in time, that is increase or decrease, loss of time or gain of time. Delta T, change in time, is equal to 1 by 2 into alpha, coefficient of linear expansion. This delta theta is temperature difference. Delta theta is equal to temperature difference, T2 minus T1. Temperature difference, T2 minus T1. T is original time of the pendulum. T is original time of the pendulum or clock. Okay, and alpha is the value will be given and half is constant. So this is the formula we will be adopting for loss or gain. Now how to get in a time t? See, this delta t by t I can write as delta capital T by t. That means during a small interval of time t, it may be 1 day or 2 days or anything, this time small t. The change in time is given by delta t by t. So delta t I can write it as delta t by t into small t. This delta t is change in time, loss or gain, t original time, t in whatever time the value, that means in what time, that means oka roja, rendu rojula, okay, depending upon the time given. What will be the change in the time period of the pendulum? So if you put the formula here, the formula finally becomes as delta t is equal to delta t by t. Delta t equation 1 em cheptundi manaki? Half alpha change in temperature T, this is delta T by T into small t. So this T cancels. So finally what is delta T? Half into alpha into change in temperature into time. So this formula you will be using for calculating the change in time period of the pendulum time. And 1 by 2 alpha coefficient of linear expansion, the value will be given, temperature difference into time. Palana time ante oka rojulo enta time marindi. Here one point you have to note in your mind. If you increase the temperature, length is increasing. It takes more time. So time becomes slower. If decrease the temperature, what happens? Length will be decreasing. So time will be decreasing. And the time ఏమవుతుంది? Fast గా కొట్టేసుకుంటుంది. And it becomes faster. Okay? If length is decrease, see, if length is decrease, time decreases. Time decreases అర్థం ఏంటి? Fastly the pendulum will be moving. So it becomes very fast. అంటే వేగంగా టైం అయిపోతుంది. So what happens? The time is faster. Okay? Here before case, the time length is increasing, time period is taking more time. Slow అయిపోయింది, ఇక్కడ ఫాస్ట్ అయిపోయింది టైం. అంటే గెయిన్. అదవుతుందా? When you increase the temperature, length is increasing. When you decrease the temperature, length is decreasing, time period is decreasing. Time period decrease means it is becoming fast. So there is a gain in time. So in both cases the formula is delta t is equal to half into alpha into delta theta into t. Okay, this is the formula you will be using best for solving such type of problems for pendulum. Clear? Right. Now let us go to the next item. In this case, loss and gain time is over regarding the pendulum. Now let us go to the next one. Let us go to the next one. So the next one is, okay, the next one will go for thermal stress. Let us see what is meant by thermal stress. Thermal stress అంటే ఏంటంటే మనం చూద్దాం. What is thermal stress? Thermal stress. You know what is meant by thermal? Thermal means heat. Stress means force acting per unit area. That means what is thermal stress? For example, ఇదిగోండి ఇక్కడ రెండు వాల్స్ ఉన్నాయి. ఇక్కడ ఒక వాల్, ఇక్కడ ఒక వాల్ ఉంది. So between these, suppose an iron rod is kept. So what happens here? Here force is applied. From this wall one force is applied, and from this wall another force is applied. That means it is trying to compress. It is trying to compress. These are the two walls. ఈ వాల్స్ మధ్యన మనం ఒక ఐరన్ రాడ్ పెట్టాం. ఐరన్ రాడ్. Now the forces are given by two walls. So it is trying to compress, decrease the length. So now we are trying to explain what is meant by thermal stress. That means due to heat, how the stress is developed. Okay. So we already know change in length delta L is equal to alpha L delta T. In before part 1 we already discussed change in length in linear expansion. Alpha coefficient of linear expansion, L is original length, and delta T is temperature difference. So this is the formula here. Now what will happen is, what is strain? What is strain? Strain in formula delta L by L. Okay, what is strain? Delta L by L. Okay. Now in the place of delta L, I can write is equation 1, that is alpha L delta T by L. LL gets cancelled. Now what is strain? Strain is equal to alpha delta T. You know what is strain now? Strain and deformation produced per unit dimension of the body. So alpha coefficient of linear expansion into temperature difference is strain. But we know from Young's modulus, elasticity. What is Young's modulus? Young's modulus is equal to stress by strain. Okay? We know Young's modulus is equal to stress by strain. So from this we can write as, you can see, we can use this one here. Okay? Because strain means alpha into delta T. Now from this, what is stress? Stress is ఎంత అవుతుంది? Young's modulus, stress Young's modulus into strain. Okay? So stress, that is force by is equal to Young's modulus into strain. What is strain here? Alpha delta T. So Young's modulus alpha into delta, but stress and into formula F by A. Stress is F by A. So Y alpha delta T. Okay. So finally F by A is equal to Y alpha delta T. Or you can also write F force is equal to Y A alpha delta T. So force acting is equal to Young's modulus, value will be given, area, that is also you can calculate, if the values are given, length and breadth, alpha coefficient of linear expansion, and delta T is the temperature difference. So this is the formula you have to adopt for thermal stress. Okay, the values will be given, the main thing is you have to apply the values here. Simple formula solve. So force is equal to, okay, YA alpha delta T. Clear? Any doubts? Okay. Now let us go to the next one. Let us go to the next item, that is density. Let us go for the next one, density. That means variation of density with temperature. Next one is variation of density, that is rho, with temperature T. That means when you increase or decrease the temperature, what happens to the density? Okay. Now we'll try to take some equations from here. That is, we know what is meant by density. Density is equal to mass per volume. Mana density ante telusu kada, mass per volume. Okay. So here you can write down change in density is equal to delta rho. We can simply write it as rho 0 initial density into gamma delta T. Just like your before equations, volumetric expansion or cubical expansion, areal expansion, linear expansion, we have some equation. Okay. Same like the delta rho. That means final minus initial density, change in density is equal to initial density rho 0 into gamma volume, coefficient of volume expansion, into change in temperature delta T. So I can write in this form. Okay. So but here what happens, you can see, this is the equation 2. Here you can simply write it as rho is equal to, see here what happens, see, rho density, that means change in density is equal to rho 0 minus delta rho. What happens here? When you increase the temperature, when you increase the temperature, okay, you can see initial minus something, that means density is decreasing here. Okay, చూడండి ఇక్కడ rho 0 is initial density, this is change in density. So initial minus this thing is equal to this, not plus. ఇంతకుముందు మన ప్లస్ వచ్చాయి L plus L0 అని, delta L అని, but here the density is decreasing. Okay, so already you have a relation, volume and density are inversely proportional. Density decrease అయితే volume increase అవుతుంది. So here what is happening here, density is decreasing, please. Density decreasing. The equation tells rho 0 minus delta rho and density is decreasing. So finally you can write like this. Okay, here from this equation, rho plus delta rho is equal to rho 0. If you take this side, left side, rho plus delta rho is equal to rho 0. Okay, or you can simply write it as rho is equal to simply rho 0 into 1 minus gamma delta T. Okay, rho is equal to, okay, rho is equal to rho 0. This is final density, initial density 1 minus gamma delta T. Gamma is coefficient of volume expansion, delta T temperature difference, rho 0 initial density, rho final density. So finally what happens here, density is decreasing. Okay, as you know, temperature increases, variation of density decreases, and volumes, you can see density decrease and volume perugutundi. When volume increases, density decreases. So the final equation for doing numericals is rho is equal to rho 0 into 1 minus gamma delta T. Clear? So after this we are going to now the second last topic, that is anomalous expansion of water. Anomalous expansion of water. Last one, second last one, very very important, this concept, that is anomalous ANOMALOUS, anomalous behavior or expansion, anomalous behavior, or you can call it as expansion of water. దీన్నే నీటి యొక్క విచిత్రమైన బిహేవియర్ అంటారు. ఇది జనరల్గా ఇన్ కోల్డర్ కంట్రీస్ we can find. So what is the behavior of this one? We'll try to understand by drawing a graph. So the graph goes like the end graph, temperature, if you take temperature versus volume. if you take temperature on x-axis and y-axis low, if you take volume V, it is observed practically. You can see this is the temperature 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. This is degree centigrade temperature on x-axis, and if it is observed that, you can see the graph goes like this up to 4 degrees centigrade. Please, you can observe, because generally ఏమవుతుందంటే 0 degree centigrade నుంచి 4 degree centigrade వరకు ఫస్ట్ వాటర్ కాంట్రాక్ట్ అవుతుంది, తర్వాత ఎక్స్పాండ్ అవుతుంది. దట్ ఈస్ ద పెక్యులర్ బిహేవియర్ ఆఫ్ వాటర్. ఫస్ట్ వెన్ యూ heat the water, it contracts 0 to 4 degrees, and after that it start expanding after 4 degrees. So in the graph you can see, as the temperature increasing, you can see volume is also increasing. As the temperature increases, volume is increasing. But when you decrease the temperature below 4 degrees, it expands. When you decrease the temperature below 4 degrees centigrade, you can see again it expands. First the temperature increase అయినప్పుడు ఏమవుతుంది, వాల్యూమ్ కూడా పెరిగింది. తర్వాత 4 degrees కన్నా బిలో చేసినప్పుడు ఏమవుతుందంటే again the volume expands. So అందువల్ల because of this nature, what happens in colder countries, you can see pipes, water pipes ఉంటాయి కదా, water coming out of the pipes will be breaking, because when the temperature is falling below 4 degrees, it expands and volume increase అయిపోయి బ్రేక్ అయిపోతుంది పైప్స్. అంతేకాకుండా మనకి రేడియేటర్స్ ఉంటాయి 4-wheelersలో, ఆ రేడియేటర్లో కూడా వాటర్తో పాటు ఒక కెమికల్ ఎలిమెంట్ గ్లైకోల్ అనుకుంటాను, glycol you have to add into the water 2 or 3 drops, so that in order to not to break, otherwise the radiator will be breaking in cold. That means during November and December, due to the temperature very less, water below 4 degrees వెళ్ళినప్పుడు ఏమవుతుందంటే రేడియేటర్లో వాటర్ ఉంటుంది కూలింగ్ చేయడానికి కోసం 4-wheelers. So it may break. To avoid that breaking, some drops of glycol is added into the water in order to not to expand and break the radiator. Okay, so these are the things, and this behavior is called as anomalous expansion of water. That means as you increase the temperature, volume first increases, but when 4 degrees kana below aithe, when below 4 degrees centigrade, what happens, again it starts expanding. So because of this only the pipes will be breaking. Not only this, we can show another graph. Not only this, that is, we can show another graph, that is temperature versus density. మరో గ్రాఫ్ కూడా చూడొచ్చు మీరు, x-axis, y-axis. This is density and this is temperature T, origin. So in this case, if you observe, say 0, 1, 2, 3, 4, 5, 6, 7, 8, so on. So here up to 4 degrees you can observe it is maximum density. Density is maximum. Taravata you can see it is decreasing. After that you can see the density is decreasing, because density depend upon what? Mass per volume. When volume increases, density decreases. మీకు ఇందాక చెప్పాను, after 4 degrees, that is below 4 degrees, when the temperature falls, volume is expanding, volume is increasing. When volume increases, what happens? Temperature density decreases. Therefore, up to 4 degrees, density of water is maximum. So after that it decreases. So this is the graph for density of water, taking temperature on x-axis and density of y-axis. Okay. So this is how you can explain the anomalous expansion of water or anomalous behavior of water. Now, one more thing you have to put in your mind, in colder countries, the aquatic culture is also safe because of this behavior only. ఎందుకంటే మరి టెంపరేచర్ మీకు తెలుసు కదా, it is falling below 4 degrees. But how the fish is survived? How the fish is survived in colder countries? Colder countries లో చేపలు ఎలా బతుకుతాయి? Because of sea. So you can see the things here. Suppose this is morning time, daytime, morning time, that is daytime, Okay, and this is night, that is cold time, during the night time. Now you observe in the daytime the temperature is high, 8, 7, 6, 5, 4, the same way, 4, 3, 2, 1, 0 degree centigrade. So in the morning time temperature is high, okay, temperature బాగా ఎక్కువ ఉంటుంది. But in the night time if you observe what happens, the temperature is less. So due to less temperature what happens, 0 degree, and it is falling below 4 degrees. So ice is formed on the surface. Surface పైన, నీటి పైన, లేక్ పైన పెద్ద పెద్ద ఐస్ ముక్కలు ఫామ్ అవుతాయి. And not only that, I just now I told you, when it is falling below 4 degree, what happens? Volume is expanding and the volume is increasing. So density is equal to mass per volume. Volume increase అవుతుంది, ఏమవుతుంది? Density decrease అయిపోతుంది. ఎప్పుడైతే density తగ్గుతుందో, the ice pieces what happens? Because of lesser density is floating on the surface. Because of the less density, it is floating on the surface of the lake and remaining water will be there. So that is why the aquatic culture fish, okay, the aquatic culture fish will be surviving. This is the main principle involved in the anomalous expansion of water. ఎందుకంటే just now I given one graph, temperature, density, okay, temperature, volume. So as the first temperature, when you increase the temperature, the volume is increasing, okay na? తర్వాత 4 degrees below వచ్చినప్పుడు again what happened, you can see in the before graph, okay, as the temperature is decreasing below 4 degrees, again volume is expanding. When volume expands, water volume density decreases, inversely proportional. So decrease అయినప్పుడు ఈ ఐస్ ముక్కలు, what are the ice pieces formed on the surface, they will be floating on the surface because of lesser density, and fishes will be going down, and that is why this fish will be surviving, and this is called aquatic culture. So అందువల్ల in colder countries fishes will be survived of this nature, anomalous expansion of water. Clear? So this one in IP also they are asking regularly for 4 marks. Explain the anomalous expansion of or behavior of the water. So by drawing all these graphs and this figure, morning time, night time, you can explain and finally you can get 4 marks. Okay? Right. So finally density is maximum up to 4 degrees and later on it is decreasing. Okay? Tarvata, now we'll go to the last one, last topic of this chapter, calorimetry. Last concept of this chapter, thermal properties of matter law, that is calorimetry. What is meant by calorimetry? Calorimetry ante enti? See, calorimetry means nothing but it is law of conservation of energy కూడా చెప్పొచ్చు. ఎలాగంటే heat lost by hot body or bodies, it is also nothing but a conservation of energy. Okay, heat lost by hot body or bodies is equal to heat gained by cold body or bodies. This is ఇది ఎప్పుడు, when there is no heat escape from the surroundings, then only it is possible. When there is no heat escaping from the surroundings నుంచి heat escape కానప్పుడు మాత్రమే ఇది చెల్లుతుంది. Heat lost by hot bodies is equal to heat gained by cold bodies. This principle is called as calorimetry. Okay, and you know heat is measured always in calories. It is measured in calories. Therefore 1 calorie is equal to 4.184 joules. Heat is measured in calories. Of course you can take it as CGS. So అందువల్ల ఒక క్యాలరీ ఎంతకు సమానం, 4.184. దీన్నే మనం 4.2 జౌల్స్ కూడా అంటాం. 1 calorie is also equal to 4.2 joule. Joule is named after scientist Prescott Joule. It is the SI unit. It is the SI unit of work done or heat also. So heat is measured in calories. 1 calorie is equal to 4.184 or 4.2 joules. Now let us learn some more things in this calorimetry, that is specific heat capacity, specific heat capacity. Let us learn what is meant by specific heat capacity. Hardly 15 minutes is left out to complete the chapter. Specific heat capacity. Generally, some authors are following C, but I will follow S only to better understanding. Specific heating in S and C vadanu. Now, what is specific heat? C, S is equal to, I will write as dQ by M into dt. And it is that quantity of heat required to raise a unit mass of substance by 1 degree centigrade. It is that quantity of heat required to raise a unit mass of substance by 1 degree centigrade. The units in CGS, calorie per gram degree centigrade. You can call this one as CGS. Or MKS, calorie badulu joule, gram badulu you can write kilogram, degree centigrade badulu kelvins. So this one same thing I can write calorie, gram inverse, degree centigrade inverse, or joule, kg inverse, degree Kelvin inverse. This is the definition and units of specific heat capacity. It is the quantity of heat required to raise unit mass of substance by 1 degree centigrade. Next one, heat capacity. Heat capacity or thermal capacity. Heat capacity or thermal capacity. This one I will indicate by C. So what is C here? C is equal to, I will write as dQ by dt. That means the quantity of heat required to the entire system, entire body by 1 degree centigrade. The quantity of heat required by the entire system or entire body to raise by 1 degree centigrade. Then units koda calorie per gram, gram ఉండదు because it is whole system కాబట్టి raise the temperature 1 degree కాబట్టి calorie by degree Kelvin CGS లేదా calorie degree centigrade inverse, or in MKS or SI system you can write simply as joule per degree Kelvin or joule degree Kelvin inverse. Clear? This heat capacity or thermal capacity depends upon mass. Let us see. See how it depends upon mass. What is dQ from the above equation? From the above equation, S M dt is equal to dQ from this equation. dQ by dt. So dt gets cancelled. Heat capacity is equal to M into S. So thermal capacity is given by mass into specific heat. So it depends upon mass, heat capacity. Heat capacity depends upon the mass. Specific heat depends upon the material. Specific heat depends upon the what type of material used. Okay? Right. Please note down. Very, very important bit questions these are. In intermediate also they are asking for 2 marks. And even in NEET and other examinations they are asking for entrance examination. Please write down. Let us go to the next one. Water equivalent. Okay? See, generally in some cases they will be asking water equivalent. Water equivalent kuda adutari majjana. What is water equivalent? Water equivalent. See, water equivalent, for example, is sketch paper undi, body undi. So, deeniki water equivalent ela kadam. So, water equivalent em ledandi chudandi. Water equivalent is nothing but mass of the water into specific heat of the water. Okay? Specific heat of the water. Very simple. Water equivalent of any item, any body is nothing but it is taken as mass of the water into specific heat of the water. Water equivalent of any vessel or any body, if they are asking, you can just simply equate to mass of the water into specific heat of the water. Mass of the water, specific heat of the water. Okay? So this is called as water equivalent. Mass of the water into specific heat of the water. Okay? So this is how water equivalent is calculated. Okay? Clear? So water equivalent means mass of the water into specific heat of the water. Clear? Now we are entering into the last one, that is latent heat. Let us see the last one. లేటెంట్ హీట్ అంటే ఏంటో చూద్దాం. అదేవిధంగా గ్రాఫ్ కూడా గీసి ఎక్స్ప్లెయిన్ చేస్తాను మీకు. ఓకే, let us draw a graph. This is also called a heating graph, the heating curves. For example, see here, x axis లో హీట్ తీసుకుందాం, y axis లో టెంపరేచర్ తీసుకుందాం. y axis లో take temperature. For example, take some ice pieces, crushed ice pieces. For example, crushed ice piece at minus 40 degrees centigrade. Try to heat it. Now what happens when you heat the ice pieces, this minus 40 నుంచి ఎంతవరకు వస్తుంది? Up to 0 degree centigrade ice solid piece వరకు it will convert the temperature. That means temperature is increasing here. Here the temperature is increasing. Minus 40 to 0 degree centigrade ice. After 0 degree centigrade ice, what happens? This ice is converted into, అంటే ఇక్కడ temperature rises, and you can see the graph, first straight line, increasing temperature. So this is up to what? 0 degree centigrade. Still it is an ice form. ఇక్కడ కూడా ice form ఉంది, negative temperature, still ice form. Now if you increase the temperature still, what happens? Completely ice is melted into water. 0 degree centigrade water. Completely it is converted into 0 degree centigrade to liquid form, in solid ice into 0 degree centigrade liquid water. This is called as latent heat of fusion of ice. That means temperature is remaining constant. ikkada temperature maradu. Keeping the temperature constant, one state is converted into another state. It is the phase change. Ante solid ice is converted into liquid ice, keeping the temperature constant. So when you convert into one phase to another phase, keeping temperature constant, that is called as latent heat. Latent heat ante enti? Latent heat ante keeping the temperature constant, one state is converted to another state, either solid to liquid or liquid to steam or gases. Okay, now what is unit for latent heat? Q is equal to ml, or Q by m is equal to L. So Q calorie, mass gram, CGS unit. అలాగే ఇది CGS. అలాగే SI యూనిట్ అంటే joule per kgs. What is SI unit? Joule per kgs. Joule per kilograms is equal to latent heat. So latent heat అంటే టెంపరేచర్ కాన్స్టెంట్ గా ఉండి ఫేజ్ చేంజ్ అవుతుంది. ఇక్కడ చూడండి, 0 degree centigrade ice is coming 0 degree water. So this is called as latent heat of fusion of ice. Temperature constant. Now if you increase the temperature, what happens? Again temperature is rising. ఎంత వరకు? Up to boiling point 100 degrees. So boiling point ఏంటి? 100 degrees centigrade వరకు వచ్చేస్తుంది. Temperature is raised. So from here to here, what happens? Liquid is converted into gas or steam. Liquid water is converted into steam, vapor. Now after 100 degrees, what happens? Till the temperature is raised, but what happens? Temperature becomes constant. Okay, again 100 degrees vapor. Okay, so 100 degrees boiling point to 100 degrees vapor. Again temperature remain constant. So 100 degrees తర్వాత మీరు వేడి చేస్తే ఏమవుతుంది? ఉపయోగం లేదు, బికాస్ వాటర్ ఇస్ కన్వర్ట్ ఇంటూ వేపర్. అలా కంటిన్యూ వేడి చేస్తే కంప్లీట్గా వాటర్ మొత్తం వేపర్ అయిపోతుంది. సో నో మోర్, అప్ టు 100 degrees only you can heat it, but more than 100 temperature will be there, 110, 120, but it converts into vapor. So here you can see the phase change, solid, temperature increase up to solid, solid to liquid, latent heat of fusion of ice, and here you can see liquid is converted into vapor. Okay, liquid is converted into vapor, and here again boiling water into vapor state. So this state is called as latent heat of vaporization. Latent heat of vaporization. అదవుతుందా? Here 0 degrees is converted to 100 degrees boiling point. Okay, so this is ఇక్కడ టెంపరేచర్ రైజ్ అయింది, మళ్ళీ ఇక్కడ కాన్స్టెంట్. ఇక్కడ టెంపరేచర్ అయినప్పుడు ఏం చేస్తారు? సో చూడండి, ఇక్కడ ఏంటి? టెంపరేచర్ కాన్స్టెంట్. Q is equal to ml, latent heat of fusion of ice 1. ఫస్ట్ స్టేజ్ Q1. తర్వాత ఇక్కడ నుంచి మళ్ళీ టెంపరేచర్ రైజ్ అయింది Q2, 0 degree to temperature, that is latent heat of vaporization, that is Q is equal to M/S delta T, 0 నుంచి 100, ఈక్వేషన్ 2. నెక్స్ట్ మళ్ళీ ఇక్కడ నుంచి ఏమైంది 100 degrees బాయిలింగ్ నుంచి 100 degrees వేపర్. సో అగైన్ Q3, Q is equal to again M into L. What is L here? Latent heat of vaporization. And you have, this is the equation 3. How many stages? Q is equal to ML, stage 1 Q1. So what is the net heat? Net heat Q net is equal to Q1 plus Q2 plus Q3. ఇన్ని స్టేజెస్లో హీట్ రిలీజ్ అయింది అనమాట. అదొద్దు మీకు Q1, Q is equal to ML, latent heat of fusion of ice, stage 1, temperature constant. ఇక్కడ టెంపరేచర్ రైజ్ అయింది లిక్విడ్ టు స్టీమ్. ఓకే, సో వాట్ ఇస్ ద ఫార్ములా? MS delta T. 2, again 100 degrees boiling to 100 degrees vapor, constant temperature మళ్ళీ. ఓకేనా? సో అగైన్ ఏమైంది? Q is equal to ML. ML అంటే latent heat of vaporization of water. సో ఈ వాల్యూస్ కూడా అదే ఐస్ అనుకోండి 80 calorie per gram for ice. What is ice? Latent heat of fusion of ice 80 calorie. And latent heat of vaporization of water ఎంత? 540 calorie per gram. These values you have to remember in your brain for numerical problems. Understanding? ఈ వాల్యూస్ మీరు గుర్తుపెట్టుకోవాలి, ఎగ్జామినేషన్లో ఇస్తారులేండి. ఓకే, ఆ latent heat of ice ఎంత? 80 calorie per gram. అదే latent heat of vaporization of steam ఎంత? 540 calorie per gram. Suppose if you want to convert into joules, you can convert 80 calorie 80 into 4.2 joules చేస్తే ఇది జౌల్స్లో అయిపోతుంది, కిందన గ్రామ్స్ ఉంటుంది. అలాగే ఇది కూడా అంతే, 540 క్యాలరీస్ని ఇంటూ 4.2 జౌల్ చేస్తే అది జౌల్లో SI యూనిట్లో మారిపోతుంది. సో యూ కెన్ కన్వర్ట్ ద వాల్యూస్ యాజ్ అండ్ వెన్ రిక్వైర్డ్. క్లియర్? సో డ్యూరింగ్ న్యూమరికల్ ప్రాబ్లమ్స్ దీస్ ఆర్ వెరీ వెరీ ఇంపార్టెంట్. హీట్ వర్సెస్ the temperature. You can see the phase change during the curves. Here temperature is increasing, constant temperature, latent heat of fusion of ice. Again temperature increasing, latent heat of evaporation. Again constant temperature, 100 degrees boiling point, 100 degrees vapor state. Q is equal to M into L, vapor. Okay, 540 value అక్కడ వేసుకోవాలి. Mass into mass of the water into latent heat of evaporation. So you can see how many stages? Q1, Q2, Q3. So these are the things you have to deal in this chapter finally, that is thermal properties of matter part 2. Now with this we'll end up this chapter. Again we'll be meeting in our next chapter, that is heat transfer. It is also called as thermal properties of matter part 2 in other words, but we won't use that term, we'll use heat transfer only. Okay, right.